Hey guys, so today we're going to talk about time complexity in competitive programming. I'm sure you've heard this term at one point or another, but today we're going to explain what time complexity means. So, in competitive programming, time is a very valuable resource during both when you're writing code and at runtime. So a time complexity essentially means how long, uh, how much time how much time your code takes to run, in comparison to the size of the input. So to measure time complexity, there is a notation called the big O notation. So it looks something like this. So there's an O and then kind of like brackets. So kind of like a function looking thing. So basically, what this means is this represents the time, like the amount of time your code is going to take, roughly. And in this function looking thing, n is going to represent the size of the input. It's going to be relatively speaking, so there isn't going to be, like, you're not going to be able to tell exactly how many milliseconds your code is going to take to run, but this is like just relatively speaking, um, the size of the input correlating to how long your code takes to run. So there are several common time complexities. So basically, common function-looking things that different code structures take to run. So the first type of time complexity is a constant time complexity, like uh, a 1 inside the function looking thing. So this basically means that this code is very fast, firstly, and well, not necessarily fast, but it just doesn't rely on the size of the input. Like you can input 10,000 as the input, or you can input 1. It doesn't matter. It's still going to take that much time. And a second type of time complexity is a logarithmic time complexity. So basically, log n inside the function looking thing. So this algorithm, a logarithmic algorithm, halves the input size at each step. So and an algorithm with a logarithmic time complexity often halves the input size at each step or iteration or whatever. And another time complexity is a square root of n. So this time complexity is slower than logarithmic, is a log is slower than a logarithmic time complexity, but is faster than a linear time complexity, which we'll discuss later. So next we have the linear time complexity. So it's a direct and linear relation to the input. So basically O of n. You can sort of say that. So yeah, this is a linear time complexity, and an algorithm with a linear time complexity goes through the input a constant number of times. And this is often like the best case scenario, the best time complexity you can have, because usually it's necessary to access each input at least once before returning the answer. And another time complexity you might see is n times log n. So this complexity often indicates that the algorithm sorts the input first, because the time complexity of efficient sorting algorithms is n times log n. And another common algorithm that uses n times log n time complexity um, is that algorithms that use a data structure where each operation takes log n time. So basically it's n times log n. So a number of data structures where each operation takes log n time. And another common time complexity you'll see is um, a quadratic time complexity. So basically n squared or n cubed. So n squared often means that an algorithm contains two nested loops. Now what this means is basically, like for example, for loops. A nested for loop is just a for loop inside another for loop. Maybe you just have to iterate something through twice or whatever. So it might look something like this. So for I in range 10, and then for j in range 10, and then some sort of code here. So those sort of algorithms often have n squared time complexity, and an n cubed time complexity is just 3 nested loops. So we can have for k in range 10. Now this would have n cubed time complexity, which sounds pretty weird, I guess. Not really. And another common time complexity you might see is 2 to the power of n, and this might indicate that, or an algorithm that has this time complexity is an algorithm that iterates through all subsets of the input elements, or the input. So for example, if somebody inputs a list with 1, 2, 3, it might iterate through like all the subsets, all the possible subsets of this. So like one subset could be just none, like none is a subset, I guess. And then there's 1, and then 1, 2 is a subject, or 1, 3, or yeah, subset, I mean, yeah. And lastly, we have n factorial. This often indicates that the algorithm iterates through all the permutations of the input elements. For example, if somebody inputs the list 1, 2, 3, now a permutation of 1, 2, 3 could be 1, 3, 2. Like basically different order. That's like different permutations. So to conclude, time complexity is basically an estimate of how long your code takes to run based on how big the size of the input is. Because especially with languages like Python, where it's relatively slow comparing to like languages like C or C++. So if you're working with larger numbers, like say 100,000, it might take longer to run significantly.